Welcome back, everybody. Section 4.4 getting ready to start. We're still working in this section on proving that triangles are congruent, but we're going to learn two new ways of doing so. In this first video for this section 4.4, we're going to use the SAS, which you might recognize as side angle side. We're going to use the side angle side congruence postulate to prove that two triangles are congruent to one another. And then in the next video, we'll go ahead and tackle this other thing called HL, which stands for hypotenuse leg. And we'll use the hypotenuse leg congruent theorem to prove that triangles are congruent. Okay, so side angle side congruence postulate to prove that triangles are congruent to one another. I want to do something similar to what I did in the previous video with SSS, where I showed you that you could copy a triangle and preserve all the side lengths and angle measures if you would simply just copy the side lengths and make sure that they're all equivalent to one another. Well, it turns out you can do the same thing where you can copy one triangle exactly if you will just if you'll copy two sides and one angle. The angle included by those two sides, as a matter of fact. Alright, now first thing I need to explain to you is what an included angle is, and we'll come back and use that quite a lot. What I'm going to do is I'm going to copy these two sides that I'm highlighting. Let me use a different color because that's not very good. And I'm also going to make sure that I keep the angle measure between those two sides the same. So I'm going to copy this angle measure here, which happens to be 90 degrees for this triangle, of course. Now, the angle that I highlighted here is the angle formed by these two sides right there. And anytime you have two segments that form an angle, the angle they form is called the angle that's included, or the included angle of those two sides. So I'm going to copy the two sides and the included angle. Now I made this pretty easy to do because I made these vertical and a horizontal line respectively. So let's make a segment that is 4 units long and a segment that is 6 units long. And you're going to see that, and I'm going to make them perpendicular to one another, so I copy that angle. And you'll see that the triangle that I create by doing so will have exactly the same side lengths and angle measures as the original triangle. Alright, here we go. So you'll notice that this segment is 4 units long, so it's congruent to this one right here. And then you're going to notice that the next segment that I've created is 6 units long, so it's going to be congruent to this segment here. And I've also made the angle, the included angle of those two sides, congruent to the included angle of these two sides. And when I close the triangle, these two triangles are going to be completely congruent to one another. Now, I can prove part of that. The other part you would actually have to bring out a protractor in order to prove, and you're welcome to do so using a computer screen or phone screen or whatever you're on right now. Now, the part that I can prove for you in terms of these two triangles being congruent is that the hypotenuses, or the third sides of these triangles, are the same. If you'll just use Pythagorean theorem, you'd have 4 squared plus 6 squared, which is 16 plus 36, 52. You'll end up finding out that this is the square root of 52, and you had the exact same measurements here. You'll still have 4 squared plus 6 squared equals the hypotenuse squared, and you'll get the square root of 52 for that. And again, use your protractor if you want to see that I'm correct, that those two angles are congruent, and that these two angles are congruent as well, and so the triangles are congruent. The point being, you copy two sides and their included angle from one triangle, it creates a triangle that is congruent to the original triangle. Alright, and so if you have two pairs of sides and an included angle of one triangle that are congruent to their corresponding parts of another triangle, makes the triangles congruent. And that's called the side angle side congruence postulate that states that fact. And so I'm going to write that in terms of the pictures that you see right here. You can see that I have two triangles of which I have two pairs of sides that are congruent to one another, and the included angle of those sides here is congruent to the included angle of those sides on the other triangle as well. Alright, so those two triangles have to be congruent by SAS. Let me write that out in words using the figures here in this picture. Alright, so you see I've labeled the parts of the triangles that are congruent to one another. Two sides and their included angle from one triangle congruent to the same on another triangle. That makes the triangles congruent. by the side-angle-side congruence postulate. Alright, let's put that to use. There are several stages of this that we need to go through. One of those is I need to make sure that you can name an included angle whenever you see one. And so I have some problems here where we're going to name the included angle between the given pair of sides. We're going to use this figure obviously to do that for each of these sets of given sides. Alright, now this is going to be very easy to do. If we want to find the included angle formed by segment LK and KM, we need to locate those in the picture first. So there are those two segments, and then the included angle is the angle that they form, or the angle that's between them. That's right here. And what's the name of that angle? Well, it's angle LKM, or you could just call it angle K since that's the only angle at the vertex, and that's what I'll do here. Let's call that angle K. Alright, next for the included angle of segments LM and MN. Well, let's locate those sides. And then the angle that they form. Doesn't matter that it's not inside the figure. It's this angle right here, isn't it, that I'm highlighting in red? Which we cannot just call angle M because there are 1, 2, 3, 4 plus angles that could be called angle M. So, but we will call it angle LMN or angle NML, your choice. Alright, go ahead and do the last one on your own if you have not already. Alright, there you see the two sides and the angle that they form right here, and that angle would be called angle JMN. That's how you determine where the included angle of two sides is. And as long as two sides and their included angle are congruent from one triangle to another triangle, it makes the triangles congruent. Well, keep that in mind now as we go through this series of pictures, in which we're going to determine, can we prove that the indicated triangles are congruent? If we can, we're going to name the postulate that we would use, which means we're either going to use the side-angle-side postulate or we're going to use the side-side-side congruence postulate because those are the ones that we know so far. We want to prove in this picture, or determine in this picture, can we prove that triangle ACD is congruent to triangle BCD? All right, so there's triangle ACD, there's triangle BCD. Well, so side, side, side would require us to prove that all three pairs of sides are congruent to one another. Now I see that one pair of sides are congruent to one another, but that's it so far. Well, can we prove that any more pairs of sides in this triangle are congruent to one another? Turns out we can. And please get used to using this. I've already told you we're going to use it a ton in this chapter. Segment DC is part of both triangles, isn't it? And it must be congruent to itself. So we'll be able to say that we have two pairs of sides from this triangle that are congruent to two pairs of sides from that triangle. Now, could we then show that the third pair of sides are congruent? You might be able to think of a way to do that, but I have something else in mind that would require a little less work if this were actual proof. And that's this. Don't we have a pair of angles that are congruent as well? Because the segment CD is perpendicular to segment AB, then every angle that they form has to be a right angle, meaning that this angle here is a right angle as well as that angle that's already marked as a right angle. Okay, so watch this. Two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle. So those triangles had to be congruent by SAS. So the answer to this question is yes, we can prove the triangles are congruent, and we would use the SAS postulate to do that. There is actually a way to use SSS here as well, but SAS is what I would go for if I were trying to write the proof. Take a look at the next picture. See if you can figure out a way to either use side, side, side or side, angle, side to prove that triangle RTS, boom, there, is congruent to triangle WTV. Pause the video, think about it for a moment, then watch me as I tell you whether you can or not. I'm hoping you said the answer is yes, and here's why. You can see that the two triangles had two pairs of sides that are congruent. These are the two sides from triangle RTS, and these are the corresponding sides they are congruent to from triangle WTV. Now, there's no way of being able to say that segment ST is congruent to segment VT, so there's no way to use side-side-side congruence postulate, but there is a way for us to determine that these two angles, R and W, are congruent, those being the included angles of the congruent pairs of sides. Why can we prove those are congruent? Well, use what you know about parallel lines in a transversal. Since segment SR is congruent to segment WV, that would make the alternate interior angles here and here congruent to one another, which means that you would be able to use side angle side to prove that those triangles are congruent. There you have it. Alright, you try with this pair of triangles. I need to mark a couple of things actually. Hold on before you do that. Now you can try it. Alright, let's talk about what you should have come up with. Now, I only told you that one pair of sides were congruent to one another, but I hope you notice that the two triangles share this segment AE, so that's two pairs of congruent sides. There's the two sides from the first triangle that are congruent to these two sides from the second triangle. Now, there's no way of showing that the third pairs of sides are congruent to one another, but what about the included angles here and there? Turns out we can't do that. Look at this. You might think that we could. We do have these pairs of parallel sides, and so the angles that they form with this transversal, specifically the alternate interior angles here and there, must be congruent to one another. Right? And so you have two pairs of sides and an angle from one triangle that are congruent to two pairs of sides and an angle from the other triangle, except that those angles are not the included angles. It's not this angle and it's not this angle right there. You can't do anything with two pairs of sides and a pair of non-included angles that are congruent to one another. It's got to be the included angles. So, no, you can't is the answer to this one. Alright, well, more side angle side stuff. We actually need to get on to some... Oh, no, not the proofs quite yet. Alright, a little more thinking that I want you to do right here. What I've given you in this problem, and you can read the directions here in a moment, I will, are two sets of things that are congruent in this picture over here. And what I'm asking for is for you to state the third congruence, or a third fact that must be known in order to prove that the two triangles are congruent using the indicated postulate. First, using side-side congruence postulate. Alright, well, I'm telling you that segment AC is congruent to segment DF, and I'm also telling you that segment AB is congruent to segment DE. That's two pairs of congruent sides. If I wanted to use the side-side congruence postulate to prove that these two triangles are congruent, I would need to know that the third pairs of sides are congruent as well. And so the third congruence that I would be looking for is this one. Segment CB is congruent to segment FE. Fairly simple, right? That makes side. Alright, take a look at the next picture. And mark down the given information on these two triangles and see if you can figure out what third congruence you must know to use side angle side in order to prove that these two triangles are congruent. Well, let's see what you came up with. We knew that we had one pair of sides that were congruent and one pair of angles, so we needed a second pair of sides that are congruent, which leaves us with either segment AB is congruent to segment DE or segment CB is congruent to segment FE. But actually only one of those will give us side angle side, because we got to make sure that these two angles are the included angles of the congruent sides. So, angle C being the included angle of those two sides that I highlighted, and angle F being the included angle of these two sides that I've highlighted, shows you that it's segment CB and segment FE that must be congruent for this to work out, SAS to work out. So there you go, that's what we need to know. Alright, now to actually do some proofs using side angle side. I'm going to need you to copy all this information down, and I did a flow proof on the last video. I'm going to do 2 column proofs in this video. 2 of them, then we're going to have one more after this. Alright, get the information copied that you need. Now you see there's 3 pieces of given information, and we're going to mark on the diagram what we can infer from each of these 3 given facts, and see if it allows us to conclude that these two triangles are congruent to one another. First of all, segment DG is congruent to segment EF. We can mark that straight away, like so. And it also tells us that those two segments are parallel to one another, so let's make that indication on the diagram as well. Now, while we've got those parallel lines there, what conclusion will we be able to make about those using those parallel lines? They got to be used for something. Well, if you'll use segment CF as a transversal, the fact that these two lines are parallel makes the corresponding angles formed congruent to one another, or in other words, it's going to make this angle CGD congruent to angle GFE. Alright, and then finally we're told that G is the midpoint of segment CF. So G, the midpoint of segment CF, that means it divides that segment into two congruent segments. This and this must be congruent to one another. Segment CG is congruent to segment GF. So, does that give us enough information to prove that the triangles are congruent? Well, absolutely. You can see that the two sides and included angle of this triangle are congruent to the two sides and the included angle of the second triangle. So we're going to be able to use the side angle side congruence postulate to prove that those two triangles are congruent. Now it's just a matter of writing those conclusions and reasons in a logical order in our proof. Well, let's try that. Go ahead and start with the first given fact. Alright, and I'm also going to do something in these triangle proofs that is not necessary, but it helps me keep track of things. If we're going to use side angle side, we need to prove that two pairs of sides and their included angle are congruent. And so as soon as I accomplish any of those things, I'm going to label it as a pair of congruent sides or a pair of congruent angles. So we've got one of the S's from SAS covered in this statement. Now, let's use the next given piece of information that those two segments were parallel to one another, which isn't showing that any pairs of sides or angles are congruent, but it's necessary in order to prove that these two angles are congruent, right? And that's actually going to be our next statement, is that these two angles are congruent to one another. And those angles were congruent because they were corresponding angles formed by parallel lines cut by a transversal. Corresponding angles postulate, in other words. And so there's the pair of congruent angles that we needed for our side angle side. Now we still got to prove why this pair of sides right here and here are congruent to one another. Remember, that was based off of the fact that G is the midpoint of segment CF, and we still have to state that in our proof before we can state that these two segments are congruent. So write this next. G is the midpoint of segment CF, which is also given to us. And that midpoint leads us to conclude this. And we know that a midpoint makes two segments congruent because that's what a midpoint is. We just used the definition of a midpoint. And all of that then has told us that we have another pair of sides that are congruent. So two pairs of sides and their included angles are congruent. Now we have sufficient evidence to conclude that the two triangles are congruent using the SAS Congruence Postulate. Fill that in, you're done with the proof. Now I won't try to tell you that that was easy, but does it make sense? I think it must. Alright, well, try one more here, and this won't be easy either, but I would like you to give it an attempt, and then you can watch me do the proof for you afterwards. Alright, you see that I'm giving you that there's a couple of right angles in this picture, and that I've got a pair of segments that are congruent to one another. See if you can use side angle side, because that's what you can use here, to prove that these two triangles VYZ right there and XZY are congruent to one another. Let's see how you've done, and let's start with the plan here. How did we get side angle side? Well, you can see that you were given that segment VZ is congruent to segment XY. That's the easiest place to start here. Let me do that. So there's one pair of sides that are congruent between the two triangles. And then you were also told that you had a pair of right angles here and there. So that's one pair of sides and one pair of angles that are congruent. Aren't right angles always congruent to one another? Alright, so where must the the second pair of congruent sides be in order for those two triangles to be congruent by SAS? Well, segment ZY is the side that helps you form this angle for the first triangle, and it helps you form this angle for the second triangle, and it happens to be exactly the same segment in both triangles, right? Reflexive property stuff. So here's the look at what we're going to try to accomplish. These two sides and this angle of the first triangle are congruent to these two sides. Whoops. And this angle from the second triangle. That's two pairs of sides and an included angle. We just have to justify why all of those are actually congruent. Then the triangles are proven congruent. Well, here we go. I'll just go in the order that information was given to us. I combined these two facts into one statement. Nothing wrong with that. They're both right angles, and that's given. And what we needed to know that for is so that we could prove that these two angles are congruent. Just saying they're both right angles does not prove they're congruent. You then have to state that they're actually congruent. So that's next. And the reason they're congruent is because all right angles are congruent, and that's exactly what I'll write. Also known as the right angles congruence theorem. Now, to this point on my checklist of showing that I had two sides and their included angles that are congruent, I've now proven that the included angles are congruent. I got to work on showing that the two pairs of sides are congruent. And the next part of that's very simple, right? It's given to us, which then gives us one of the pairs of congruent sides for our SAS. And then the other pair of congruent sides was this side that the two triangles shared, segment ZY. Now watch the way that I write this, and I'll restate the reason why I do this kind of thing. And what I'm referring to is this. Instead of saying segment ZY is congruent to segment ZY, I said segment ZY is congruent to segment YZ. Now you don't always change the order there, but the reason I did is because this first triangle here is a reflection. You'd have to flip it in order to make this triangle right there. And when you flip the triangle, the Z from the first triangle would correspond with Y from the second triangle. So since I put Z there, I'll put Y there and so forth. All right? Hopefully that makes a little bit of sense to you. Won't count against you if you don't, but you are much better off if you understand that. Now there's our second pair of sides for our side, angle, side. Right? Now it didn't matter if I listed them in the order, side, angle, side order. In the picture, those are two sides and an included angle that are congruent to one another. So we can prove that the triangles are congruent. And that was done using the side angle side congruence postulate. Alright, at this point you ought to understand what the side angle side congruence postulate is, and I hope you can compare that with the side congruence postulate from the previous section. And we're going to throw in several more between the rest of this section and the rest of the chapter. Great. Thanks for your attention again. I'll see you next time.